Geometry definitions. So your note template looks like this. For each of the concepts, and I just have a little piece of the note template, you're going to write a definition, draw a diagram, and you're going to show what the symbol is and how to name the particular feature, the geometric term. I'll have all of that in your notes for you, and I'll help you fill this out. There are some concepts that we don't need all 4 boxes. Maybe it's just a definition, and so we can always use that box if we need more space, or we can put an X over it if it doesn't apply. The other thing we're going to write in is the number of dimensions, right? So I'll get you started with that. A point here is 0 dimensions. A line is 1 dimension, and this is also in the notes as we go along. Array is 1 dimension. I don't think I need an S there. 1 dimensions does not sound right. And a line segment is 1 dimension. Right, so we'll be filling that all out as we go along. And there'll also be some places for you to stop and answer some questions. In the diagram of a football field, the positions of players are represented by points. The yard lines suggest lines, and the flat surface of the playing field can be thought of as a plane. 3 terms, points, lines, and planes, are the building blocks to define other terms in geometry. Geometry depends on a common understanding of terms, such as point, line, and plane. Because these terms cannot be mathematically defined using other known words, they're called the undefined terms. But we are going to describe all of those terms, and then use those terms to define other terms. The term geometry is derived from the Greek word geometria, meaning to measure the earth. In its most basic sense, then, geometry was a branch of mathematics originally developed and used to measure common features of earth. And it has developed to be so much more than that now, though. Plane geometry deals with figures that can be represented in 0, 1, and 2 dimensions, or extended into 3 dimensions. Geometry can deal with more than 3 dimensions, but we're going to stick with plane geometry, and we're not going to go more than 3 dimensions. Points and lines. So a television picture is composed of many dots placed closely together. If you look very closely, you'll see the spaces. Right? So it looks like it's a solid line, but when you look really, really closely, you see some spaces there. However, in geometry, a line is composed of an unlimited, infinite number of points. There are no spaces between the points that make a line. You can always find a point between any 2 other points. The line above would be called line AB or line BA. Notice the symbol there is a line with 2 arrows. I added an extra point there. I added point C. So how else could the line be named? Well, we could also call that line CA or AC or CB and so on. BC. Okay. Notice we use 2 points on the line, and we use a line with 2 arrowheads. So let's look at some definitions. All right, so the first one for your notes, we've already written in that a point is 0 dimensions. Definition: a point is an exact location in space. It is represented by a small dot, but it has no size at all. Feel free to abbreviate so we can fit into the boxes. Feel free to add additional space if you need to. So for point, for instance, you want to write in that it's an exact location in space. You don't have to write full sentences. And represented by a small dot, no size, right? That would be some ways that you could abbreviate that. The diagram, we could show here, this is point A, or we could show several points. Use either one. Use 1 point or use several. Notice that we represent the location with a dot. For naming points are labeled with capital letters. So this would be point A, B, or C. Right? So you've got your definition, your diagram, and naming, and your dimensions. And so that would fill all 3 boxes. Right? So that's what you'll write for the boxes so you get the hang of it. Right? So you've got your, next to point, you'd write 0 dimensions. For definition, you could write what I've underlined in red. And then for the diagram, you can use either one of those 2. And then for naming, points are labeled with capital letters. All right, let's move on. All right, so underline 1 dimension. All right, so definition, a line has 1 dimension. It extends without end in 2 directions. It's represented by a line with 2 arrowheads. A line has no width. Right, so you could write in what the words that are in red. We've already written in 1 dimension, but for definition, extends without end in 2 directions. Right? You can also add in has no width. We'll, for the representation, we have that by naming, so you don't have to write that down. Diagram. All right, so I have 2 diagrams here for you. You can either write the line here with X, Y, and you can label that as line XY or YX. That order doesn't matter. You'll use a line with 2 arrowheads. Or if you like the other diagram there, we have line DE, ED, or FD. All refer to that line there. So either one of those 2 you can use for your diagram. For naming, right? Lines are named, and you can write in what's in red. Lines are named by one of 2 ways. Either any 2 points or a single lowercase letter. When it's a single lowercase letter, the line has to be labeled that way. So for instance, that line is labeled line M. Right? So I can call that line M. That M is not a point, it's just a way to label the line. Include that we have arrowheads to show that the line continues without end in opposite directions. Any 2 points on a line can be used to name a line. The order the points are listed does not matter. Right? So here we've labeled, called that line DE, line ED, line FD. We could also call that line DF, or we could call that EF. What happened to my arrowhead? There we go. EF. Or because it's labeled, we could also just call it line M. All right, so those are the ways you label lines. Make sure you use the correct symbols when you're naming your geometric features. All right, let's continue on. So remember that even though only a few points are marked, a line is composed of an infinite number of points. You can always find another point in between 2 other points. So it's an infinite number of points on a line. We just don't always write them all in. Actually, we couldn't write them all in, right? It's infinite. 1 dimension. Right? So continuing on, we have ray. So definition, a ray is a portion of a line that starts at an initial point called an endpoint and continues infinitely without end in the opposite direction. You can write in what's marked in red. For the diagram, we can use either one of these, right? So you can either show ray GH here, or you can show ray XY or XV. Ray XY and ray XV are equivalent. You're starting at X and going in the direction of V or the direction of Y is the exact same thing. Because I don't have any other points here, I could not possibly label ray GH as anything but GH. Right, so ray GH and ray HG are not the same thing. There are 2 ways to name a ray. Right, so number 1, name the endpoint first and then name any other point on the ray. Since it extends forever, you can pick any one of them. The symbol for a ray is an arrow. This does not have 2 arrowheads on it. It's just a single arrow. that shows it's going in one direction only. It's always drawn facing to the right. That's just a convention. So even if the ray is going the other way, we just put the arrow to the right. Your end point is the same as your starting point. Right? It's not where you end, it's where you start. Right? So I think you should write that in your notes. Right? And so here we have here I have our second example, our second way to name a ray. We can also name a ray with a single lowercase letter. So this ray would be called simply ray Q. Right? So two different ways to name a ray. Either the end point and any other point on the ray, or if it's labeled with a lowercase letter like this one is, we could call it ray Q. That Q is not a point because it's not a capital letter, so it has to be a label for the ray. If any part of this lesson you got confused, you need me to go over it with you, I can go over it with you and give you more examples as well. Right? This is just so you, this is you know, a chance for you to get the notes, to go over this concept, but then we can spend more time on concepts that you need to review more, ones you find trickier. So order is important when we name a ray. This is ray AB. The end point has to go first. Rays start at an initial point. In this case, it's endpoint A and continues indefinitely in one direction. If we have ray BA, that has a different initial point. That would start at B, not at A. And it would actually be going in the other direction, through A. Right? So ray AB and ray BA are not the same. They have different initial points. They extend in different directions. Right? The second ray here, because it has a Q on it, could also be called ray Q. Right? But do not, ray AB and ray BA, they're not interchangeable. They're not the same thing. You have to start at the end point, the starting point. Continuing on with our one-dimensional things, line segment. So a line segment is a portion of a line or ray that extends from one point to another point. A line segment has a finite length. Right? It goes from one point to another. Right? So there we have your definition. For the diagram, you can draw either one of these. You can show line segment. This would be line segment LM. Notice our symbol here is just a line, no arrows, because it doesn't keep on going. It's finite. It starts at, it goes between L and M. Can't really say it starts it, but it goes between those 2 points, L and M, and that's it. We could also call this line segment ML with the line no arrowheads. So a segment is named with its 2 endpoints and a bar written over top of it. The order of the endpoints does not matter, but it does have to be the endpoints. So here we have, so I've added point C on my line segment here. And now if I were to add up line segment AC plus line segment CB, together they would make up line segment AB. Or I could also call that line segment BA. So the order doesn't matter, but it does have to be the endpoints. And you can add segments and get one bigger segment. So here we have a problem. We want to find 6 different names for the line that contains points U, V, and W. Right, so when we're naming a line, we use any 2 points on the line, and the order doesn't matter. So I can call this line UV, and I put the arrow above. Or I could call this line VU. I could call this line WV or VW, or what did I use it? WU or UW. Right? Any of those. There's our 6. 1, 2, 3, 4, 5, 6. Any of those 6 could be used to name that line. If we had more points, we would have more ways to name the line. Point of intersection. Right? So intersecting lines, right, that's going to be 2 dimensions. The term intersect is used when two lines, rays, or line segments meet. That is, they share a common point. The point they share is called the point of intersection. So intersecting lines are in two dimensions because they're going in different directions. But the point of intersection, that's going to be a point, so that's going to be 0 dimensions. For point of intersection, for the definition, you can use the postulate, two lines intersect at exactly 1 point. So for intersecting lines, that's 2 dimensions. The definition for point of intersection, two lines intersect at exactly 1 point. Here we have our diagram, right? So point of intersection there. So you can just draw the this particular diagram, the two lines intersecting and their point of intersection. For symbol and naming, right, we just name where those two lines intersect. So lines QT and RS intersect at point K. All right, so the intersecting lines are 2 dimensions. Let's also add, though, that the point of intersection, we'll just put it right here. I'll put it in another color, red. The point of intersection is 0 dimensions because it's a point. Two lines together create 2 dimensions, and we'll talk about that when we look at planes. All right, and then we have a diagram showing a point of intersection and how we name that point of intersection. Okay. Collinear points. All right, so that would be 1 dimension because these are points that lie on the same line. So for a definition, we have 3 or more points that lie on the same line. Also add to your definition, 2 points are always collinear. You can always draw a straight line between 2 points. So if you have 2 points, they're always collinear. Even if a line's not shown between them, you can draw a line between them. So when we talk about collinear points, we're talking about 3 or more points. For your diagram, this would be the diagram here for collinear. Right? So there we have our points that lie on the same line there. There's no symbol, right? So you can either use that for your diagram or just put an X in it, but there's no symbol. Non-collinear points, right? That would be 2 dimensions, right? Because they're not all lying on the same line. Our definition is 3 or more points that could not be connected by a single line. Right? So here we have non-collinear points. You can use that for your diagram, and you can add, you can't connect all 6 points with a single line, right? It would take more lines than that. And there's no naming or symbol. This one was just a definition with a diagram. Right, so just as a reminder, any 2 points are always collinear. Right? You can always draw a line between 2 points. Right? And I think this one actually is in your notes as a separate term. So I believe you have the postulate, any 2 points are always collinear. Next to that, you can put 1 dimension. For the definition, you can always draw a line between 2 points. And then you can use this one for your diagram, right? 2 points with a line, right? That will be your diagram. So this one, right below that word diagram, right where it says diagram, use that picture for your diagram. And again, no symbol, no naming. So I think I'm going to stop here, and then we have some example problems that we'll do together, and then I have some problems for you. Bye for now.